For our video, we decided to record a small metal ball dropping into a vase full of water. After putting this video into the tracker, we noticed that the t versus y graph had a smooth curved line until about 0.11 seconds, which is where the ball hit the water. The ball experienced an upward force from the water, which caused an uneven shift in velocity. This can be seen in the straight line. The curved line shows that the velocity was changing at about an equal rate. This will be further explained later on in the video. We also noticed that in the velocity versus time graph, that the line was a straight slope line until about 0.06 seconds. After that, the line became nearly flat until about 0.08 seconds, where it took a steeper slope and reached the maximum velocity of negative 5.48 meters per second. After that, the velocity sharply decreased until it hit the bottom of the vase and hit nearly 0.0 meters per second. After looking at this graph, you can see that the ball didn't fall that much of a distance. It only fell about 4.47 meters, which is 47 centimeters. As for the velocity, though, it fluctuated a ton. It was nearly 0.0 at the end, but at one point it even got as high as negative 5.47. The starting point was not exactly 0, it was actually about negative 0.07.
Our video demonstrates Newton's third law. For every action there is an opposite but equal reaction, because as the ball hits the water is also pushing back up on the ball.
I noticed that the impact is less on the ball by hitting the water rather than the table, because similar to an airbag during a car crash, the water cushions the fall by increasing the time and decreasing the force on the ball.
When the ball is initially dropped, it has the most potential energy, but as it is dropped, the potential energy decreases and the kinetic energy increases until it hits the water. When it hits the water, the potential energy doesn't convert into kinetic energy as much.
Before the ball drops, there is only the force of gravity acting upon it. Once it starts dropping, there is the force of gravity and air resistance acting upon it. Lastly, once it hits the bottom of the vase, there is the force of gravity, normal force, and water resistance acting upon it.
Nice.
I came in like a